Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada, on camera control, doing video, all the behind the scenes chit chats and postings and ghostings and all that good stuff. We've got a fun-filled show for you tonight with lots of products and videos and news and updates and tutorials and open hardware and more, including the code. So why don't you tell them what's tonight's code?
Believe it or not, the code has never been SOC. After like 15 years of doing the show, so I have to check to make sure we haven't.
When would we have used SOC?
I don't know, but there's a lot of words that we've used and a lot of words we haven't.
Well, and we have never used SOC.
We've not used SOC. So the code is SOC, 10% for the Adafruit store all the way up until 11:59 p.m. Yeah, there's something with SOCs, but the code SOC. We'll be talking about some of our live shows. We got a JP's product pick of the week highlight video. We got some manufacturing videos. We got a speed up. We've got an eye on NPI this week. It is ST. This is, of course, brought to you by DigiKey. We got a bunch of top secret. We got new products. We're going to answer your questions. We do that on Discord, adafruit.it/discord. Join all like 39,000 of us. All that and more on, you guessed it, Ask an Engineer. Okay, so first up, code SOC. We have free stuff.
Okay, that's right. When you order from the Adafruit shop, we give you some free stuff. $99 or more, you get this beautiful PCB coaster. $149 or more, you get a Pro Micro Pinout compatible microcontroller board featuring the RP2040. It's got like USB-C and lots of pins and semi-QT port, so it's great for beginner microcontroller projects. $199 or more, you get free UPS ground shipping in the continental United States, and $299 or more, we've got our Circuit Playground Express all-in-one board. That's great for beginners learning to code or do electronics without having to use any soldering stations or tools. Just need a USB cable, plug it in, and you're ready to go.
Okay, we do a bunch of live shows each week. We just finished doing show and tell. Please watch it afterwards. Wherever you watch our Adafruit videos, YouTube is a place where a lot of people watch it. And all the projects are really good, but if you scrub to the end, you'll see an excellent
Necrocaster.
Excellent prop maker.
Yeah, so cool.
Project by Chris. Good work, Chris. Check that out.
Love it.
On Sundays, we do from Desk Lady Ada, including Great Search.
Yeah, check it out.
Last week was the Z80.
Yeah, I talked about the Z80, and I showed off the two Trinkies, the TRS Trinky and the NeoPixel Trinky.
And you can check out what's on Lady Ada's desk. On Tuesdays, we do JP's product pick of the week. Here is the highlight from this week.
It is the Cricket hat for Raspberry Pi. Right here, there's a Raspberry Pi 5. You can see I have the Cricket plopped right on top. What I've got plugged into my Cricket are DC motor here. There is a hobby servo here. We could have up to 4 hobby servos plugged in. And then I have one of these 8 signal input outputs as a analog input that I'm using for a potentiometer, a little potentiometer breakout. So what I'll do is I'll just run a Python program on here. We have the Blinka libraries installed, and what that means is we can use all those great CircuitPython commands and libraries that you know and love. So if I run that, we've now got control of that servo and the motor speed, forward and backwards. We can stop it right there. It is the Cricket hat for Raspberry Pi.
And tomorrow is JP's workshop, and then on Friday, deep dive with Scott. If you want to see highlight of what Scott showed on Show and Tell, that's your time and place. I mistakenly said 3 p.m. It's actually 2 p.m. on Fridays, but it's still around at 3 p.m. too. But do check it out, 2 p.m. Pacific time. All right, let's go to some Python on hardware news. We're going to do something a little different this week. Of course, check out the newsletter, but this is breaking news. So this is not in the newsletter yet.
It is after the newsletter came out this week.
But Espressive acquires a majority stake in M5SAC, which makes a lot of sense when you think about it. So, Lady Ada, why is this a big deal, and why did you say, hey, let's talk about that?
Well, first off, M5 Stack and Espressif are doing a lot of MicroPython development. And a lot of people use MicroPython and Python hardware on the M5 Stack hardware. And we have CircuitPython for many of those boards as well. They're great because they're like physically like enclosed. Like what we don't do as much injection molded stuff. We tend to do like breakout boards and stuff where you would wire it up, and it's for DIY electronics. That's my jam. But one thing that M5 Stack does really well is they make stuff with enclosures. And they've kind of figured it out. They've got like this rugged plug and play system. But I thought it was interesting because I think this will mean that there's going to be a lot more of the newer chips coming out in like the M5 format. And like I said, I think they're gonna, as the chips are getting bigger and bigger and more complicated, I think they're going to have to move to doing MicroPython and other Python hardware, because like once you get to the P4 series of chips, like there's just so much complexity that compiling the code is just going to take forever. Especially since I think Platform IO is no longer like the number one suggested IDE integration for Espressif. I think they said like they still support it, but it's not like the primary support. So I think it's a good opportunity for them to pivot into MicroPython.
Yeah, I think this makes a lot of sense, because if you're Espressif, you need kind of a dedicated showcase of your hardware.
Mm.
You need to show what all of it can do, and you need to be able to plug in all these things together, and you can wait for people to produce these things. Wait till someone adopts it, but it's not necessarily available to developers because some of it's in finished things.
I like how this is like, it's like the next step up. It's like stuff is like enclosed.
Yeah.
I think it'll also help if they have tighter integration with Espressif, they'll probably their designs will probably get technically more, not that they're not bad now, but it's like they're going to get more advanced.
Yeah. So you'll see this in the newsletter next week, but we wanted to have this breaking news now. We used to have a segment called Maker Business, but this interleaves it. So I think if you do Python on hardware, you're going to be pleasantly surprised, because anything that has Espressif is now going to have more M5 Stack stuff, and you'll be able to do more MicroPython.
Yeah, they think they have a fork of MicroPython for a lot of their boards. It would be cool if it got integrated into mainline.
Yeah. All right. The newsletter is available every single week on Adafruit Daily. Get it delivered to your inbox. Ping, 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 ping. Go to adafruitdaily.com. It's a separate site because we do not spam you. We wanted a completely separate site. All right, let's do some open source hardware news, which is our guides and more. Lady Ada, what's on the big board this week?
Okay, I got some guides. So Liz did a guide for the B&O 055 and BMP BFF. She's going to test on a couple more platforms, but just like a little 10-DOF sensor for people to use. And now we have code that you want to get started immediately. Like, we have libraries for both sensors, but like, she has an all-in-one example, I think, that's ready to go. JP did this cool ESP32 Itsy Bitsy, like this board that we made. I was like, oh, it'd be great for making a little Bluetooth wireless adapter. And so he, taking a break from doing a lot of CircuitPython. It's an Arduino, but it takes advantage of the over-the-air programming that's available in Arduino for the ESP32. He also did some low-power development as well. So he got down to like, 77 microamperes of current, which is pretty good for sleep while waiting for a button press. So like basically when you're done playing, you just put it down, and after 30 minutes or whatever, or you can customize it, it'll automatically go into a deep sleep mode and wake up when you press the start button. So there's no on-off switch.
Yeah, we have a little video from JP that we're going to show.
And then more updates for Raspberry Pi, and Liz also did the 2 analog switch guides as well.
Okay, we're gonna play this little controller video, and then we'll do some New York City factory footage, a little bit of 3D printing, and then we're gonna go right to NPI.
Okay.
comes some factory footage. This one is a little artsy, so enjoy. Alrighty. Next up, some 3D printing. We got to speed up this week.
It's spring break, but we'll have more 3D printing stuff next week.
More coming soon. Alrighty, and don't forget the code is SOCK. And you get all this free stuff.
Love socks.
Let's just jump right into Ion MPI.
on MPI.
Brought to you by DigiKey. Ion MPI, we look at the latest and greatest new product introductions, hence the name NPI. This week is ST. Lady Ada, what is this week's Eye on NPI?
Okay, this one, I thought this was pretty cool because I'm starting to see more situations where like the price of microcontrollers is getting so small that companies are just like throwing microcontrollers with anything into like a mix and making little bento boxes. And we've covered, I think, before, like ST, we had their LoRa radio combined with a STM32 G0 series. Well, this week it's the ST Spin 32. Actually, it's the G02, but the image says F02. So this is a combination chip that's a 3-phase brushless DC motor controller with a ARM Cortex M0 STM32 G0 chipset. I have the exact chipset later, but 64 megahertz clock, 64K flash, 8K RAM. So not like a big chip, but it does have a bunch of peripherals. It doesn't have USB, it doesn't have CAN, but it does have I2C, SPI, UART, timers, ADC, etc. And it's built all into one package so that you can have really tight integration with your sensors and your brushless controller, which you probably, instead of, you could have it all in one, and like your main microcontroller is also connected to the controller, or you could have this as a peripheral that's controlled by a more complicated controller, that's like your main microprocessor, and then it can communicate over I2C, SPI, UART, and all the timing, temperature monitoring, power control, whatever your complex motor control can all run on a dedicated core, but at a low price. So most hobbyists, and especially me, like the motors that we tend to use are from this image. Oh, I can't even is it possible to
Squish it?
unsquish it?
Squish
It
it.
was squished because I want to show the motors.
Show a little.
Yeah, there you go. So you've got your stepper motor on the right, your DC motors at the bottom, and then 2 servo motors. And servo motors actually are just like DC brushed motors, but with a feedback control system. So a lot of people, when you're making a small toy or a small robot, you'll use a DC brushed motor, which you see below. They have 2 wires. And the way they work is there's a permanent magnet and then the commutator in the middle. the armature, and it has these, I think the yellow and blue things in these images are the brushes. And they literally are brushes like made out of metal that allow the stator to maintain contact with the electrical input even while it's rotating. And these work fine. The only issue is that they are they have a lot of electrical noise. The brushes eventually do go bad, and so the motors have to be replaced. Um, and I'm trying to remember the third thing is. I think they're basically they're unreliable long term. They eventually do break, and they're sensitive to vibration. So the other alternative is the other motor that I showed was a stepper motor, and a stepper motor doesn't have brushes. It's a brushless design because instead it has 4 or some multiple of 4 windings, and there's a magnetic toothy um, uh, uh, axle and then like a toothy outer ring. And as each phase of the motor activates, those teeth move the motor forward by 1 degree or 1.8 degrees at a time. So this isn't the thing about stepper motors is they're not very fast, but they do have like precise motor control and they can like stay still. So what we want though for if you have something that isn't a toy, like anything that is a white good or automotive or industrial technology where you want to have the motor last a long time and you want it to spin quickly so a stepper motor isn't going to be fast enough, you want a brushless motor, which looks a lot like a stepper motor. It's kind of the same idea. You have multiple of 3 usually, uh, number of coils, and as they turn they rotate the inner magnetic axle around, and there's no brush. But the trade-off is the DC motors, you just give them like DC power and they just run. You give it plus 5 volts or negative 5 volts and it rotates plus or forward or backwards. You can PWM to change the speed. With brushless motors, you have to have precision control of the 3 phases. So each of those, like the stepper, each phase has to be turned on and off exactly at the right timing to make sure that you have the smooth motion. So you can't do it without like digital electronics controlling it. This is like a lovely floppy disk um, motor. And that said, they're not that much more expensive than DC motors. It's just the driving circuitry is a little bit more complicated. So normally you would get a 3-phase brushless DC motor driver like this, L623Q from that stock the DigiKey from ST, and they often either have SPI or sometimes I2C, but usually parallel control, where you control each of the 3 phases, and you tell it which phase you want on and off, and then you also read back EMF to tell how much torque you're putting out, or you measure the current, or you measure the voltages. But then you do have to wire this up. And again, the timing has to be perfect. Like you can't miss a single pulse. Unlike the PWM for a DC motor, which you can just set a timer going and it just runs. With these, you have to like have each phase go. And sometimes there's a peripheral that helps you, but you still have to, maintain this, to maintain smooth speed. And if you want to speed up or slow down or to brake, you can't have any interruption. So you would have normally like a dedicated microcontroller or a dedicated microcontroller peripheral. For the ST Spin 32 G0 series, you've got your G031, which I think we covered the G0 series. It's like the STM's new low power, like super low power, low cost ARM Cortex series. And in the body of the chip, which you see here, like the outer round rectangle is the body of the chip, inside is bonded basically one of those parallel BLDC drivers on the right with your classic STM32 on the left. So they're connected together, but in one package. Just makes wiring simpler. It's like you get this tight integration. You don't have to worry about having 2 components. You pick and place one thing. Probably going to be more reliable. And also it has really good specs. So the chip is programmed basically identical to the STM32G0 you expect. It's exactly the same chip inside, which means you would use the same STM32 cube, the same SWD debugging, the same IDE, same program. Everything's the same. And then you can use any of the peripherals. Obviously, they're going to pick a chip that has example code ready to go to control the brushless motor driver. So you could probably get started with their example code that's like designed for this sub chip type. And it doesn't have like it's not a ton of flash, not a ton of RAM, but it is enough to like I said, I think it would be really good as a sub processor. Well, either if you have a simple white good where it's like, okay, you want to control a motor on like a blender or something, and you want to control some simple buttons and maybe have some blinking LEDs or something, temperature monitoring, this would do a fine job at that kind of white good. Or you could have it as a sub processor where you have like your Cortex M7 or greater M4 or M33 running your device and handling the GUI and the touch and whatever, and then it kind of subcontracts out the commands for the motor control to this microprocessor. Probably, if you're looking at driving multiple motors, this is going to be nicer than trying to like time sequence it on your M7 while it's also doing GUI stuff, while it's also doing touch or sensing. Also, of course, if you want to connect this to something that's running like embedded Linux, where you're not going to get very good real-time reactivity because it's not a real-time operating system. Another nice thing I saw is it does have, of course, all the inputs, and some of them are 5-volt tolerant. So that'd be handy if you want to connect this up to a CAN controller as well. And then the way it works is that it's your QFN. I think it's a 72 QFN, but like not really because like a lot of the pins are missing. So all the pins that will be connected inside to the BLDC controller are not brought out. And then instead you've got on that right-hand side, isolated out are the 3-phase controllers. So those are for each of the 3 phases for the H bridges that you'll have to connect on the other side. There are a couple versions of this. There's the individual motor drivers and controllers at the bottom, the L, 6234, etc. And then on the upper half are the ones that have you see the ST spin 32. The F0 is the previous version. This version goes from the STM32 F0 series to the G0. Again, it's kind of a more modern version, more available, lower power. There's an eval board if you want to get started, so you can see the ST Spin 32 on the kind of the bottom middle there. And then in the middle right, you see the 6 FETs and a little bit of circuitry. So you can't connect the motor directly up to this chip. It doesn't have the power capability because you need like gigantic FETs. So instead, you're going to have to pick up 6 FETs, which they can recommend, or you can just check out the eval board and what they used. 2 for each phase to make the bridge, and then that will control each coil in your motor, and you can the drivers can do like 60 plus amps or 100 amps or whatever, however much you can heat sink, but you don't need separate MOSFET drivers. The MOSFET driver is built into the ST Spin 32, so it does simplify things quite a bit because you don't have like 2 stages of control. This is the IGBT used on that eval board. So like I said, it can do up to 650 volts, 10 plus amps. And then the chip itself is in stock and available. There's a version that's can do, I think, half an amp or like 400 milliamps and 800 milliamps for the MOSFET drive or the FET drive. And then 600 volts and I think 300 volts. So definitely like this is like a beefy driver. I think this would be cool as like a little all-in-one board with like CAN on the other side, and then you just plug in your motor and you have a standalone CAN control that also has the temperature monitoring and power monitoring built in.
Good pick.
Yeah. I like this.
I on NPI.
All right, rolling right along. Don't
Okay.
forget code SOC. Let's go right to new products.
Bags. People actually asked us to put these bags in.
Yep.
So we actually don't tend to use these zip top bags anymore because we have auto bagging, which is less wasteful and faster and lets us put the work order number on each bag. But if you do want some bags, we are selling them in packs of 100. Good deal, basically half the cost you would normally pay for them. Pick them up, they're anti-static. They're great for storing little electronics. You can write on them with a Sharpie marker. And we have a lot in stock, so
Okay.
grab them.
Thanks up.
Okay, next up we have the Electromage Pixel. Oh my goodness, wait. I forgot the name of it. Can you see the back? What's the name of it? Pixel Blaze. It's the Electromage Pixel Blaze. There you go. So this is an all-in-one ESP32 powered and driven and controlled NeoPixel or DotStar controller. And the cool thing about Pixel Blaze is they've got like really great software. And this was recommended to us by cosplayers who said they loved using these in as costumes because you can use their app or website to do like pixel mapping and pixel control, animation control, and it's really, really simple. And you can share animations and like load them in dynamically. So it's a very small board, but it's like super packed. And this one has tons of flash and tons of RAM to be able to control like a billion neopixels if so desired. And of course, load lots of animations dynamically.
Okay. And then
There's also an add-on sensor board if you like. So there's a lot of GPIO brought out on that Pixel Blaze standard. And if you want to add accelerometer, this has, I think, a list 3DH, has a little microcontroller, has a microphone, and has a line in so that you can use it to do there's also a light sensor. So you can have it react to light sensing, to the microphone, to audio, to frequencies, or to motion. So like a little add-on plug board to just make sensing a lot easier that integrates directly with the Pixel Blaze XL.
okay. And then next up.
This is still the sensor board. I think he's got twice as many.
Yeah, I got twice as many.
Okay. And then this is the Pico version. So if you're doing like a tiny project, maybe you want to tuck it in a shoe, little wearable or a prop. This is the Pico version. It's still got ESP32. It's got a little Pico chip, which I've used this chip. It's great. And then it still has the level shifting and the button and the Wi-Fi control, the web and the app and everything. But instead of having this gigantic board, it's really minimal. And you just give it 5 volts power and ground, and then you have 2 NeoPixel strands or 1 DotStar strand output.
Ready, next up.
Okay, next up, we've got, if you want to do USB host stuff on a Xiao or a Pico, we've got the new USB host BFF, which comes with a Max 3421E, which we've got teeny USB support for. So it's really easy to add USB host to Arduino or actually CircuitPython coming very soon, where apparently they got merged in. We're going to do some testing and then we'll do some demos. So here, this is just a demo showing a enumeration, but you can do USB serial input or mass storage, so USB key or disk drive. You can do keyboard or mouse. And then I think in CircuitPython, we even have MIDI device input. So to connect, I think if you can show over here, just because it's confusing, because you're like, why is it a micro USB? A USB type A wasn't going to fit. So you can use an on-the-go cable, which they're like only a couple bucks. And you probably even have some because they're used on the Pi Zero. And then it turns it into a USB type A. And then you can also turn on and off the power. So you can hard reset your USB devices. If desired, just bridge that 5-volt end jumper on the back. I think this will be neat. We do have for the RP2040 BitBang USB host, but it's, I think it's tough because then you don't get to use any PIOs. You're using a whole core. This is supported by, ESP32, RP2040, SAMD21. So like pretty much any chip that has enough space, like a 32U4 wouldn't have the space for it. But pretty much any modern microcontroller chip can use the Max 3421, especially if it has teeny USB support. There's also kind of a well-known USB host library that is separately developed that people use and has a lot of arcade controllers supported.
Again, so tonight, besides you, lady, our community, our team, our customers, everybody in the open source world is
Socks. It's a DVI sock.
that's right.
So DVI sock is based off of Ren 6339, I think is his name, is a circuit developer for the Raspberry Pi Foundation or trading company. And they designed this sock to demo the Raspberry Pi Pico's DVI output, which means it can drive HDMI monitors. And we have a DVI cowbell, but once in a while you really just want to like make a very simple board that has just DVI output. You don't want to like have a whole thingamajig. So this is basically a version of the sock. It's just a slight modification to the design, but it has the same pinouts. So as you can see here, the easiest way to use it is you actually solder your Pico or your Pico W, either will work, onto the end there. And then it's got the 8 GPIO on the bottom. Pins 12 through 16 are used for the 3 lanes of TDMS output and then the clock differential pair as well. Even though you're supposed to connect the 5-volt pin, turns out you don't have to, although it is brought out. You can see on the side, the CEC, the util, the 5-volt and the ground pins are separated out if you so wish to connect to them and read like the EEPROM on the monitor, which again, we don't do on the RP2040. We tend to just set the output to be like 640 by 480 or whatever and just like pipe data out. But it's a low cost board, simple board, just to add DVI output for your Pico and, you know, again, solder onto the end, or you can use pin headers if you wish. Either way, you can make it plug and play.
That is new products.
New.
All right, don't forget to go to Sock. 10% off in the Universe Store all the way up to 11:59 p.m. tonight. You can put your questions over on Discord, adafruit.it/Discord. We'll be getting those soon. Let's do some top secret first.
Okay.
Got a few videos and more, and then we have a couple things we're going to show off. All right, Lady, what is this?
Hey, I got my prototype for my TRS AT accessibility Trinky. This is a USB plug-in board with a SAMD 21E18. So it's a Cortex M0 that can run Arduino or CircuitPython. It's got a NeoPixel and a TRRS jack. What that means is that it's a 4-pole 1/8-inch audio jack. So you've got tip, ring 1, ring 2, and sleeve. And like this is a little breakout that makes it really easy for me to prototype and test with it. And accessibility switches tend to use just tip and ring. They're like a mono audio, but you know, it's the same size as a TRS, and with the TRS you can connect multiple switches. So, you know, even without a splitter, just wiring up these so that we have one button through this little, like, you know, plug and play thing over here, goes to the tip and ring, and then another button goes to the other ring and the sleeve. And then I've got this plugged in here. It's got some demo code running. And then I've got some CircuitPython code that, you know, sets the non-used pins to be ground. Sets them to be ground. And then it uses the keypad on the tip and the ring too. And whenever it detects a pressed event, it can write with HID. So if I open up Notepad here and I press these buttons, you'll see as I press them, one button says hello, and then, you know, the other button says A. And so you can customize. You can even have it do mouse stuff or like complicated, you know, multi-line text inputs. So it can be really good for easily customizable accessibility stuff. And here's the best part: no soldering is required. It's like you can plug and play everything. This plugs right in, and then you can use terminal blocks with just a screwdriver to add up to 4 switches. So I don't know. It's gonna be kind of cool.
All right, Lady, what is this?
Okay, this is our Ethernet feathering, which is a really popular add-on board that allows you to add Ethernet to any of our feather boards. And it has a WizNet, I think it's like a WWiz 5500 mag jack. And we have to test it. And the best way to test it is to actually send and receive Ethernet data. But one thing I've noticed is not everyone who is testing the boards always has like an Ethernet jack near them. Like sometimes they're a couple feet away and they don't want to get like a 50-foot cable. So I was like, oh, instead of plugging into our router at Adafruit, let me make like a standalone Ethernet testing jig. So I've got here is a Metro 328, like Arduino compatible, with an Ethernet shield. And then I've got this. What is this? This is a crossover connector. So it turns an Ethernet cable into a crossover, which means you can connect point to point. And then I've got code running on both of these. Right now they're just checking if the Ethernet cable's connected. And what it does is it sends a UDP packet to a broadcast address. And then when it gets a response, it prints out the response and it sends like hello, and then it gets back, world, and that's how it works. So if you see here, as I plug in the cable, it sends a UDP packet, and then over here, this flew by, but it responded with the contents world when it got a packet of hello. And that's how we know that we have full bidirectional communication working on Ethernet. So now we don't need a separate router. But this is also a really handy thing to do if you just have like 2 Arduino boards or microcontroller boards, and you want to have like a really good connection between them that's better than serial and can go, hundreds and hundreds of feet. Ethernet is a great option. And of course, you've got feather wings and shields available. Just don't forget that crossover connector.
All right, Lady Ada, what is this?
Okay, I just got my prototypes for the Pixel Trinky end, and I'm ready to test them out. So this is an at SAMD 21E18. So it's a Cortex M0, 256K of flash, 32K of RAM. And basically, I just have a little level shifter here. You can see it's a dual shifter that'll shift from 5 volts, the 3 volt signal to up to 5 volts. And then over here, I've got a ground, a 5 volt output from the USB, and then a data and clock pin. And what this is for is like really easy driving of either 2 NeoPixel strands or 1 dot star strand. And the clock and data are on an SPI port. So you can do dot stars really, really fast too for, if you want really fast updates for your pixels. You can also, of course, do your standard NeoPixels from 5 volts, and you can do it in CircuitPython or Arduino. So just like a really easy, simple plug and play, no soldering. There's little terminal blocks so you can quickly connect your wires up without any soldering or tools. And I think it'll make it really easy to make computer-controlled, colorful light effects.
All right, what's this?
Oh, this is a rendering of the Pixel Trinky. Showed off.
And what's this?
This is a tripler for picobells, because I'm doing a lot of picobells. And this one, it basically expands the doubler and then adds a iSpy connector, so you can like connect e-ink or TFT displays, like pretty much TFT displays, very easily, and a NeoPixel. So I got prototype PCBs yesterday, so hopefully we'll get this together. I think this will be popular because you can have a Pico and then 2 add-ons.
Top secret.
Back in the vault.
All right, cool. For all the new products, don't forget to go to SOC.
Socket
Free
to me.
stuff. Let's do questions.
Yeah.
We only have a couple, which is
That's
good.
great.
We're going to get out of here and put
8:45.
baby to sleep. All right. The first question was, there was a couple of questions about new product availability. If it is not in stock, just sign up.
Yeah.
And you'll get a email the second it's back in stock. Right now, since the chip shortage is over, usually things are, not out of
Things are
stock for too
coming,
long.
but things are coming back. But there's a couple stragglers. Yeah.
All right. Any help for an ESP32 S3 QT Py with a UFL connector?
I'll be
Or
honest, when I make UFL versions, we don't sell that many.
Hmm.
People say they want them, but they don't. But
Okay.
maybe I'll add it to the list.
All right. Here's a suggestion for your network tester. Could you make the network port on the source at MX so it could auto sense whether the cable is straight or crossover?
It's just not supported from the WizNet. Like I tried, it needs a crossover cable.
All righty. This might be it.
Okay, easy.
Easy peasy.
Last chance.
Go once, go twice.
Okay. That is
Thanks, everybody.
Sure.
We'll see everybody next week. Thanks for joining us. This has been an Adafruit production. Don't forget the code is SOC. Use it to support a New York, USA-based open hardware company manufacturing here
I'm
in the USA.
I'm making stuff.
Yep.
If you buy it, it
Thanks so
helps
much.
me make more stuff.
And pay our team. Here's your moment of Zener.
Bye-bye.